There we go. Okay, so today's lesson, what is the it's tax day. Tax day. So if your parents haven't done their taxes, they probably better get it done today or ask for an extension, okay? So, the objective day. What we're going to do today is we're going to reduce, multiply, and divide rational expressions. Okay, so a couple of things about what we're talking about. Reduce makes sense, okay? Like reducing fractions, right? The rational is a fancy word for fraction, okay? We call them expressions because there's no equal signs. It's just an expression, right? There's no equal signs. There's no solving. So we're just taking fractions. We're going to reduce fractions. We're going to multiply and divide fractions, following the exact same rules that we learned in 6th grade, okay? Now, what we got to be careful about is this. We can't divide by 0, okay? So any value of x that causes us to divide by 0, we can't use, okay? So cannot divide by 0, okay? All right, example 1. What are the excluded values of x? So before we do anything, what we ought to do is factor. Okay, before we do anything, let's factor. Because it's easier to see the excluded values if you factor. Okay, so if I factor the numerator, I'm going to get x plus 3, x minus 2. And if I factor the denominator, I'm going to get an x plus 4 and an x minus 2, okay? So, since I cannot divide by 0, if, right here, see where my pin is? Right there. If x were to equal 2, you guys watching? Put the phone away. John, listen to me. If x were 2, 2 minus 2 is 0, right? And then 0 times this expression, this would be 6, but who cares because 6 times 0 is still 0. You cannot divide by 0. So my excluded value is this. X cannot equal 2. Because if x is 2 in the denominator, you're dividing by 0. X cannot equal negative 4, right? Because if x is negative 4 here, you'd have negative 4 times negative 6. Negative 4 plus 4 is 0. It'd still be 0. You cannot, so x cannot equal negative 4. Those are my excluded values. Now what I can do is just like we did on our warm-up. I go back and sneak a peek at our warm-up. What I can do on this fraction, remember how we reduced it? We reduced it all the way down. I can take this fraction and reduce it by canceling my x minus 2's, right? So a simpler version of this fraction would simply be an x plus 3 over an x plus 4, okay? Now, here's something to think about. The x minus 2 is gone in the final answer. However, in the original problem, you still can't have 2, okay? Does that make sense? So the exclusion, don't divide by 0, disappeared for one of them, right? It did. But in the original problem, you still cannot have x equal 2. Those are the exclusions, okay? Does that make sense? What's the domain of this function? Well, x can be anything. You throw anything in for x. Anything except these two values. So the domain, you're going to say the domain is this. X equals everything, all real numbers. Everything. It could be 5, it could be 100, it could be 1,000, it could be 1,000,000,000, it could be 1.3, but it cannot be everything. But it cannot be x cannot equal either 2 or negative 4.
What about negative 3?
Negative 3 is okay. Great question. Really good question. What happens on negative 3 is you get a 0. I'm glad you brought that up. So you get a 0 at x equals negative 3. So it crosses the x-axis at negative 3. We're going to look at that later, okay? Really good question. So 0 on the top is okay. 0 on the top is just the number 0. You with me? 0 on the top is 0. The number 0. And the number 0 is a real number, right? But 0 on the bottom, it's going to make Cookie Monster sad, right? It's going to be an asymptote. Okay, example 2. Simplify expression and find the excluded value. So right at the bat, first of all, I know that x cannot equal 0. You guys okay with that? Think about it. If x were 0 here, I'd be dividing by 0. I'd get 6 times 0 squared is 0, and I'd be dividing by 0. But let's simplify it. So first of all, I'm going to factor what I can. So I'll factor again. And I'll common factor out a 2x squared. And in the numerator, I'm going to have an x minus 4, okay, over my 6x squared. So I'm going to factor first, and then it gets pretty easy at this point. I can reduce, I'm just going to reduce this fraction here. See, I'm going to reduce that. So I can reduce an x squared with an x squared, and I'll make the 2 and the 6 a 1 and a 3. Okay, x squared cancels x squared, right? And then 2, 6, think of this fraction. 2, 6 becomes 1/3. So what's left? Well, not much. There's a 1 on top times an x minus 4. I don't need the 1, but there's the 1. Don't need the 1. And in the denominator, I have a 3. I do not need the 1. Mm-hmm.
Why do we find the common factor is just both the denominator and the top part?
Right, that's what I did. Yeah. Now another way to look at this problem, and it can be done this way also, it might help. You could have done it like this: 2x cubed over 6x squared minus 8x squared over 6x squared also. Okay, that's another way to do it, because that term divides into both. If you do it that way, you're going to get the same answer. I just prefer to common factor first. Yeah?
Okay, so how did you get to the 1x?
Okay, 2, 6.
Right.
2, 6 is 1/3. See my 1/3?
So the x squared cancels out?
Yeah.
Oh.
X squared over x squared. You're like, hey, that's not that bad, is it? Yeah. Okay, example 3. So before we do anything, let's factor. On example 3, let's factor. Remember, I told you if you can't factor, it's not going to be good for you. You have to be able to factor today, okay? So if I factor the numerator, I'm going to get an x minus 1 times an x minus 4. And if I factor the denominator, I get an x minus 1, another x minus 1. Okay, now, first of all, the excluded values. Excluded values. X cannot equal 1. Can't equal 1. It can equal 4, though. Great question, Daisy. Daisy brought up an important point. It can equal 4, because that gives me a 0, but it can't equal 1. If it's 1 here, you divide by 0. If it's 1 here, 1 minus 1 is 0. So it can't be 1. Everybody agree with that?
So you can divide 0 by things, but you
Yes.
can't divide by 0.
Yeah, let's give a Cookie Monster example. Okay, if you have 0 cookies and 5 friends, how many cookies does each friend get?
0 then?
Yeah.
And so if you have 0 friends and 5 cookies.
It doesn't make any sense, right? How do you divide those 5 cookies up? You can't, right? So anyway,
Just eat them yourself.
cancel, but you'd have to be included in that group. Okay, then
Count yourself.
x minus 4 over x minus 1 is the answer. You guys see I cancel the x minus 1, x minus 1? You agree?
Yeah.
Okay. Not too bad. Okay.
What's the domain, Mr.
Oh, my domain is all real numbers. Thank you. X, my domain. Thank you, Caleb. X equals, doesn't say domain, but we can. X equals all real numbers except x cannot equal 1, right? It doesn't say domain, but we got it anyway. I like that extra effort, Caleb. Okay, you guys ready to turn the page? You guys good? Okay, example 4. Now, example 4 looks like a big, ugly problem. But if we factor, then we're just going to cancel. Okay, this is how it works. We factor, and then cancel. Okay, so first of all, let's factor. Okay, so in the numerator, x squared minus 2x minus 3 is an x minus 3, x plus 1. Okay, so I factored x squared minus 2x minus 3 into x minus 3 times x plus 1. In the denominator, I'll factor x squared minus 1 into an x plus 1, x minus 1, okay? The second fraction,
That would equal
x squared minus 2x minus 63, I'll factor the numerator into an x minus 9 and an x plus 7, right? Because 9 times 7 is 63, but I need negative 9 and a positive 7 to make the negative 2. In the denominator, x squared plus 4x minus 21, I'll factor that one into an x plus 7, x minus 3, x plus 7, x minus 3. Now, with the fractions, you can anything on the top is fair game with anything on the bottom. Does that make sense? Because you're multiplying all the way across, right? So anything on the top is fair game with anything on the bottom. So this x plus 7 will cancel with this x plus 7, right? This x minus 3 is on top, and it would cancel this x minus 3 on the bottom, okay? And, oh, this x plus 1 will cancel with this x plus 1. So a lot of canceling, so it reduces really nicely. So this is a super fancy version of what we had maybe in our warm-up, okay? In our warm-up, just had numbers, right? And we just found that we could cancel, but this is just a super fancy version, the same type of process except for with x's, okay? So what's left? An x minus 9 over an x minus 1, okay? If you can factor, you're okay. You really are. If you can factor, you're okay. If you can't factor, sorry, bummer, we've been doing it for like months and last year, right? Okay, example 5. Since it is divide, you see the division? We're going to flip the second fraction. We're going to flip this fraction. So let me rewrite it. So you invert and multiply the second fraction. Okay, so let me rewrite this. X squared plus 2x minus 15 over x squared minus 3x minus 40. Okay, and then I'm going to flip it, invert and multiply. So I flip the second fraction. X squared plus, I'll make it a 1x to help you out, minus 72. And then we'll have the x squared plus 8x minus 9. Okay, so when you divide, you flip the second fraction. And now we're going to factor. Okay, so now we're going to factor. That says factor. So x squared plus 2x minus 15 factors into an x plus 5x minus 3, right? Thank you. And in the denominator, x squared minus 3x minus 40, let's see, what is that? 8 and 5. X minus 8, x plus 5, right? My second fraction, x squared plus 1x minus 72, probably a positive 9 and a negative 8, right? So probably x plus 9, x minus 8. And my x squared plus 8x minus 9 is probably going to be a positive 9 and a negative 1, right? So I'll go x plus 9, x minus 1. Okay, so here comes the fun part, if you can call it fun. But here comes the fun part. Cancel, right? So let's see. X minus 8 with x minus 8. Doesn't matter. So anything on the top, because we're multiplying all the way across, right? We're multiplying straight across. So anything on the top will cancel with anything on the bottom. X plus 9 with x plus 9, right? X plus 5 with x plus 5. So this fraction reduces very nicely into an x minus 3 over an x minus 1, okay? Thumbs up? Okay. Let's look at our journal. Let's look at our journal today and see what our journal has to say to add to this, okay?